needle of metal racing at 130,000 miles per hour, older than the Earth, colder than any comet, and now slicing through our solar system. For months, 3I Atlas drifted in silence, predictable, distant quiet. But last week something changed. Its reflection brightened, its orbit trembled a shift so small, yet enough to raise the alarm. Astronomers said it was a small reaction, but NASA believes these changes could reshape what we know about this comet. Inside that ancient ice-like isotopes, older than the Sun, 7 billion years of memory now stirring awake. Let us follow 3I Atlas through the void and see how it rewrote what we thought we understood. Imagine you're standing on the dusty plateau of Mars. The horizon stretches endlessly, an ocean of rust and gold that seems to shimmer under a sky half as bright as Earth's. Above you, the thin atmosphere trembles beneath a pale sun barely strong enough to warm the metal skin of the Perseverance rover beside you. The wind hums against its hull, soft, metallic, ancient, like the slow breathing of a sleeping machine. Look up. Phobos, the small moon, rushes overhead, circling Mars in just 7 hours. You can almost see it move, crossing the sky faster than any moon on Earth could dream. And somewhere beyond that faint light, a new traveller has entered the scene, 3I Atlas, the third interstellar object ever found by humankind. For weeks, every radio dish and telescope across the solar system has waited for this moment. From orbit, NASA's Mars Reconnaissance Orbiter adjusted its high-rise camera to its sharpest possible setting, 30 kilometers per pixel, enough to spot a skyscraper from the distance between New York and Boston. The European Space Agency's Mars Express tuned its spectrometer, hunting for the faint glint of sunlight reflecting off the comet's icy skin. Even Perseverance, buried under that thin Martian air, lifted its camera toward the copper horizon, waiting for a streak of light to pass. The calculations were razor thin. A margin of less than half a degree meant missing the target by thousands of kilometers the span of North America. To stay locked, gyroscopes spun with impossible precision, balancing, whispering to the void. You can almost sense their stillness, the hush before light arrives from across the abyss. Then came October 3rd, 2025. Alignment perfect. 3I Atlas swept past within 30 million kilometers of Mars, the width of a cosmic breath between two worlds. For the first time in human history, an interstellar object would be photographed not from Earth, but from another planet. Scientists called it a window of centuries, a moment so precise that missing it would mean waiting generations for another chance. Inside mission control, the atmosphere was like the pause before a heartbeat. Rows of monitors flickered, voices fell to whispers. Every packet of data mattered, every photon, every spectral line. Numbers told the truth, but what they hinted at was something deeper, a doorway through which the human mind might step, if only for a second, into the unknown. And yet beneath the equations and telemetry, a quieter thought lingers. What if this traveller carries the chemistry of another star? What if its dust once circled a sun that died before ours was born? You feel a tremor, not of fear, but of scale. The awareness that knowledge itself is shifting beneath your feet. The rovers keep listening, the orbiters keep watching. Streams of data flow home like invisible rivers of light, millions of kilometers long. In those faint pulses, science and wonder breathe together, and for a moment, standing at the edge of another world, you realize how rare it is to witness the universe when it decides to speak. For a while, the signals continued, a steady heartbeat pulsing from Mars to Earth, faint but faithful, like a pulse echoing through metal and dust. Across 180 million kilometers, light itself was speaking in Morse code. Then, without warning, the rhythm changed. At first, it was nothing more than a hesitation, a skipped beat between packets of telemetry, a delay so small it could have been interference from solar wind. But inside mission control bodies leaned forward, eyes narrowed, the air tightening like a held breath. On the monitors, the feed from Mars Reconnaissance Orbiter flickered once, then steadied. Across the Deep Space Network antennas in California, Madrid and Canberra rotated, automatically relocking onto the distant relay. For a few minutes, everything seemed fine, then the line went flat. A single band of silence, thin and absolute, cut across the black screens like a scar of light removed. You can almost feel it, that electric stillness before disbelief arrives. $1 billion eye had just blinked and no one knew if it would open again. Engineers moved fast. They checked voltages, transponders and uplinks. Nothing failed. Power levels were nominal. The spacecraft was alive but silent. Somewhere above the red planet, an orbiting machine still watched, but its voice no longer reached home. And on Earth, As if choreographed, another kind of silence unfolded. Breaking news, a temporary government shutdown, funding lines frozen, non-essential NASA systems placed in standby. To the public it was politics. To the scientists in Pasadena it felt like a cosmic riddle. The feed had gone dark on the very day 3i Atlas was closest to Mars. Coincidence or a decision made behind the static? You and I can almost see the scene, a room lit in pale fluorescence, coffee cooling beside untouched keyboards, the hum of servers filling the space where human voices should be. Moments ago, photons from another star had been whispering through a dish in the Mojave Desert. Now only the faint hiss of the cosmic background remained, a sound older than life itself, pressing softly against the speakers. Engineers refused to stop listening. They sent a low-band ping to Mars Express, the European orbiter still awake on the far side of the Red World. Her reply came slow, intact, delayed by distance, but unmistakably alive. The issue wasn't the cosmos, it was access. The American feed was sealed, awaiting administrative protocols, officially routine, unofficially unbearable. And so curiosity began to bloom in the silence. What if those missing packets contained something strange, an anomaly, waiting to be verified before the world could see it? It wouldn't be the first time images were held back, but the symmetry was too precise. A celestial event muted at the same moment a nation fell quiet, as if the universe had chosen to whisper and humanity had chosen that instant to cover its ears. Imagine yourself in that control room. The lights hum overhead, steady as a heartbeat. Mars spins slowly on the central screen, red, calm, indifferent. Every person knows what they were about to see. The first image of an interstellar traveler captured not from Earth, but from another world. Now that moment drifts away, lost in bureaucratic stillness. Outside, the night over Pasadena deepens. Telescopes keep searching, though their feeds are muted. Somewhere between Mars and the stars beyond 3i Atlas continues its silent voyage, untouched, unseen, carrying whatever message it brought from the dark. And so, the first mystery begins, not what was discovered, but what was not allowed to be seen. Because in science, as in the cosmos itself, absence can speak as loudly as light. The cameras have spoken. For a few brief hours, data flowed like rivers of light across the void, like a pulse echoing through metal and dust. Across 180 million kilometers, nearly 500 times the distance between the moon and us, light itself was speaking in Morse code. Then, without warning, the rhythm faltered. At first, it was only a hesitation, a single skipped beat between packets of telemetry, a delay so small it could be mistaken for a breath in the solar wind. But inside mission control, shoulders stiffened, eyes narrowed, and the air grew dense as if the room itself had stopped breathing. On the wall of screens, the feed from Mars Reconnaissance Orbiter flickered once a flash, then calm. Across the Deep Space Network, antennas in California, Madrid, and Canberra swiveled in perfect unison, relocking onto the invisible thread stretching toward Mars. For a moment, everything held steady. Then the line went flat. A band of silence, thin, absolute, cut across the monitors like a scar where light had been erased. You can almost feel that charged stillness before disbelief arrives. $1 billion eye had just blinked and no one knew if it would open again. Engineers rushed forward, hands on keyboards, voices low. They checked voltages, transponders, uplinks. Everything nominal, power levels perfect. The spacecraft was alive, but quiet. Somewhere above the red planet, an orbiting machine kept watching, yet its voice no longer reached home. And on Earth, as though choreographed by irony, another kind of silence unfolded. Breaking news scrolled across control room screens, a temporary government shutdown. Funding frozen. Non-essential NASA systems placed in standby. To the public, bureaucracy. To the scientists, a cosmic coincidence sharp enough to hurt. The data feed had gone dark on the exact day 3i Atlas brushed closest to Mars. Coincidence or decision? You can picture it, the control room under harsh fluorescent light, the hum of servers replacing human speech coffee, cooling beside untouched keyboards. Just minutes before, photons from another star had whispered through a dish in the Mojave Desert, traveling longer than the entire history of human flight. And now only the hiss of the cosmic background remained, a sound older than life pressing softly against the speakers. The engineers refused to give up. They sent a low-band ping to Mars Express, the European orbiter still circling the far side of the planet. Her reply came slow, but whole proof that the distance was not the enemy. The problem was access. The American feed was locked sealed by administrative protocol, officially routine, unofficially unbearable. Curiosity began to bloom in the silence. What if those missing packets carried something strange, an anomaly, waiting for verification before release? It wouldn't be the first time images were held for review. But the symmetry was too exact a political pause, mirroring a celestial alignment, as if the universe had chosen to whisper, and humanity in the same instant had covered its ears. Imagine yourself there. The lights hum overhead, steady as a pulse. On the main screen, Mars turns slowly crimson and unmoved. Every person knows what they were about to see, the first clear frame of an interstellar traveler captured from another world. Now that moment drifts away, lost in bureaucratic stillness. Outside, the night over Pasadena deepens. Telescopes keep searching, though their feeds are muted. Somewhere between Mars and the stars beyond 3E, Atlas glides onward untouched, unseen, carrying whatever story it brought through the dark. And thus the first mystery begins, not what was discovered, but what was not allowed to be seen. Because in science, as in the cosmos itself, absence can speak as loudly as light. Hours pass. The blackout fades into a waiting game, a hum beneath the silence. The data streams flickered, then steadied again, thin threads of information whispering across the void, as if light itself were stitching a wound between two worlds. Columns of numbers appeared on screens, neat and exact, but beneath them pulsed a kind of unease, a heartbeat missing every few beats. The scientists stared not at what they received, but at the gaps between what they didn't. We expected revelation, bright, cinematic, loud. We imagined discovery as an explosion of light, a headline, a miracle neatly framed. Instead, we found precision dissolving into quiet, as if the universe had sighed and refused to speak again. Yet in astrophysics, even silence has a pattern. A blank line is not nothing. It is information in disguise, absorption, interference, perhaps even intentional muting. So the engineers turned their analysis toward the void itself. They mapped the missing seconds like cartographers of darkness, plotted timestamps of every lost pulse, and began to turn nothing into data. Each pause became a coordinate, each missing bit a dot on a wider map, a geometry of absence drawn against the cosmic noise. Imagine standing beside them, bathed in the dim blue light of the monitors. Outside, Earth sleeps a pale marble suspended in ink. Mars turns slowly, its canyons flashing dull silver in reflected sunlight. Between those worlds stretches an ocean of radio waves, billions of kilometers wide, threaded by a signal no thicker than a whisper. You watch the graphs rise and fall like tides. You begin to sense it. The silence isn't withholding truth. It's teaching patience. It asks us to wait to listen without expectation. And so they do. They wait through orbital delay, through the bureaucratic freeze of systems and funding, through the endless hum of machines that never dream. They wait because waiting is part of science, the humility before uncertainty, the surrender that lets the cosmos speak in its own time. Then, almost casually, the signal returns. A single message flashes on the screen, telemetry nominal. No anomaly, no drama. Just the mechanical heartbeat resuming as if nothing at all had happened. But everyone in that room knows better. Something shifted in that interval, something invisible yet undeniable, like a breath drawn before the next sentence begins. Perhaps that sentence starts with an image, a single frame taken by a camera on another world. Inside that frame, a streak of light stretches across the Martian sky, too sharp, too deliberate, as though drawn by intention rather than chance. Was it a glitch of the sensor, a reflection off the rover's lens, or the first faint glimpse of something built not born? The silence ends, but its echo remains. Through that echo, a form begins to emerge, a line, a shadow, a question with shape. We are being guided again toward the next mystery waiting in the dust of Mars. The silence had shape. It lingered in numbers, in static, in the pause between data streams, until suddenly the universe exhaled again. Not a roar, not a signal, just an image. One frame, enough to change everything. Timestamp October 4th, 2025, 0217 UTC. Source Perseverance rover, navcam left. File size small. Too small at first glance to hold anything important. Yet when the technicians opened it, they froze. Across the copper Martian sky stretched a streak of light, thin, brilliant, unnaturally straight. After hours of waiting, the cosmos had chosen its moment to speak again. At first, they assumed a trick of motion, blur the camera, catching a meteor or a bright particle mid-flight. But the metadata disagreed. Exposure time 0.03 seconds. Tracking rate locked on Mars's horizon. Background stars sharp, motionless. Only the streak-defied geometry, a vertical scar of light running for hundreds of pixels, impossible in its precision. Now imagine standing beside the rover itself. Dust curls around your boots, fine as powdered rust. The air is so thin you can hear your own heartbeat through the helmet. Above you the sky glows not red or blue, but copper like old metal left in sunlight. And there it is, a bright line moving not across the sky but through it, as though someone had drawn a single stroke of pure light through air, too ancient to resist. Inside, JPL engineers enlarged the frame. The line resolved into a cylindrical form luminous at both ends, its gradient inconsistent with any natural reflection. Spectral data spiked around 720 nanometers, the wavelength of heated nickel or metallic vapor. Every physicist in the room held their breath. Natural comets scatter light. They shimmer, they fade. They do not burn like polished metal. Cross-checking began immediately. High-Rise aboard the Mars Reconnaissance Orbiter was retasked to image the same coordinates. Hours later, another faint echo appeared, the same object elongated, symmetrical, its proportions matching what Avi Loeb would later describe, length 4 times its width. If the measurements held 3i, Atlas spanned more than 800 meters taller than the Burj Khalifa, drifting in silence above Mars. You can almost hear the control room quiet, electric. Artifact, someone murmurs. Stacking error. Another voice. No blur on the stars. A third. Then what is it? No one breathes for a moment. The hum of the computers replaces speech. Imagination begins its quiet, inevitable work. Was this an illusion, a trick of optics, an echo of compression? Or had the rover by chance captured the side of an engineered object, a probe, a fragment, a relic from beyond the heliopause? If true, this would be the first image in human history to show a possible artifact of non-solar origin, photographed from another world. From Cambridge, Avi Loeb responded within hours. His explanation was elegant long exposure stretch caused by alignment drift. The navcam stabilizers might have overcorrected, turning a point of light into a line. But the math refused to stay silent. Exposure too brief, drift too small. The correction required would demand a speed the rover could not achieve. In the language of physics, something didn't add up. Perhaps the universe delights in ambiguity. Every explanation contained its own contradiction. The more precisely they measured the stranger, the certainty became. 3i. Atlas hovered at the edge of understanding, a paradox suspended between data and dream. You stand with them now, eyes fixed on the magnified frame. The streak glows faintly, a silver filament against the red dusk. It could be a trick. It could be a message. And somewhere behind that gleam, a question waits, bright, patient, deliberate. No one says it aloud, but everyone feels the same unspoken truth. Perhaps the silence was never empty at all. Perhaps it was only the beginning of what wanted to be seen. The moment an image travels from a machine to a human mind, it ceases to be data. It becomes a story, and stories invite interpretation. Few living astronomers understand that tension more intimately than Avi Loeb. When the image of the cylinder reached his inbox, he didn't gasp or gesture. He leaned closer to the numbers. Outside his office in Cambridge, the night was still, a chill air drifting across the Charles River servers, humming like distant bees in the silence. On his screen, the Perseverance framed side by side with its calibration logs. In that contrast, Loeb saw what most had missed. The rover's navcam uses a synchronized shutter mechanism. If one module lags even a few milliseconds, a bright object can stretch, turning a point into a line. It's not alien, he told reporters later. It's engineering. Yet his tone was neither dismissive nor absolute. He spoke like a mathematician holding a fragile equation between his hands. The simplest explanation is instrumental, he said. But simplicity isn't always the truth. He began to rebuild the geometry of that fraction of a second. Using Perseverance's pointing data, he traced the arc of 3i Atlas as it crossed the Martian sky. At a distance of 30 million kilometers, even a minor parallax shift could elongate the object's form. The phenomenon was plausible, a stacking artifact caused when sequential frames align imperfectly. Stars remain sharp because the camera locks on them. The moving target blurs because its motion defies the reference grid. To test it, Loeb ran a simulation. A synthetic bright dot swept across a digital sky at the velocity predicted for 3i Atlas. The result, a streak nearly identical to the rover's frame. When he showed it to colleagues, the tension in the lab eased slightly. The explanation fit at least on paper, but curiosity never rests where comfort begins. One researcher leaned in. If it's just a smear, why are the edges symmetrical? Another countered, the brightness isn't even both ends flare like mirrors. Comets don't do that. Polished metal does. Loeb adjusted his model again. He added reflectivity variations, phase, angles, possible lens, flare. Still the symmetry persisted, a perfect cylinder, mathematically neat and physically improbable. He sat back silent as if the image itself were waiting for him to ask the correct question. Now, imagine you're in that Cambridge office with him. Equations scrawl across digital whiteboards. Coffee has cooled beside a half-eaten protein bar. The clock ticks faintly above the server hum each second, reminding you that the universe owes no explanations. On the screen, the silver streak refuses to decide what it is. In later interviews, Loeb spoke carefully. If we treat every unknown as evidence of intelligence, we lose science. But if we dismiss anomalies too quickly, we lose discovery. That was his balanced skepticism as discipline, imagination as method. Behind him, history lingered. Years earlier, he had argued that Oumuamua's motion couldn't be explained by simple, outgassing a stance that made him both visionary and pariah. Now with 3-Ira Atlas, he walked the same narrow path between ridicule and revelation. He wasn't defending mystery, he was defending the right to look again. Later in a quiet blog post, Loeb wrote, "Data is a mirror. Sometimes it reflects what's out there, sometimes it reflects what we expect to see." He invited others to re-examine the raw frame, the exposure settings, tracking code, metadata gaps. Beneath the precision of his language, another sentence seemed to breathe between the lines. What if the artifact isn't in the image, but in the way we understand seeing itself? Consensus eventually settled on Loeb's hypothesis, a technical cause, rational, contained. But deep inside the archive, the image remained shimmering like a riddle made of light. A line across a sky that had never known blue. The numbers explained it. The heart did not believe it. Outside, Mars rotated on indifferent and red, and in the frame, the cylinder kept its impossible symmetry, a perfect vertical echo of something human language had not yet learned to name. Proof demands repetition. Stories may shimmer, but data must echo itself. Across the world, laboratories lit up like constellations, each one trying to make the same line of light appear again. To separate illusion from event, to see whether the universe had truly spoken, or if we had only misheard it. In Pasadena, under the long white glow of laboratory lamps, engineers at JPL built a digital twin of the Perseverance nav cam. Every variable was copied, a Sentinel-03 second exposure, f12 aperture horizon, locked average Martian dusk luminance equal to a cloudy desert evening on Earth. A bright moving dot was projected across the model sky at the predicted angular speed of 3i Atlas, roughly 0.04 degrees per second, like watching a grain of sand fall across your field of view. When they stacked the frames, the result appeared almost instantly, a thin luminous streak the shape of motion itself. Relief murmured through the room. Physics for the moment had restored order. But then one analyst leaned closer. In the simulated blur, the brightness faded evenly end to end. In the real image, the ends flared brighter, as if light had struck metal rather than pixels. No optical model could reproduce that symmetry. They rotated, the simulation shifted angles, adjusted algorithms. The flare moved. In the real photo, it stayed still, anchored to the frame, unmoving, disobedient. So they turned to another eye in orbit. Mars Express, faithful and tireless, had captured low-resolution optical data just minutes after Perseverance's image. Its spectrometer registered a sharp spike 705 nanometers, a Gaia, the nickel metal signature. 2 instruments, 2 locations, 1 improbable coincidence. Imagine the tension in those rooms, the hum of processors, the soft scrape of paper as notes are passed across the table. No one dares say extraordinary. Instead, they whisper the safer word, inconsistent, a word that hides wonder behind discipline. The investigation deepened. A ground-based control test began in Arizona using the Mastcam-Z calibration rig under simulated Martian light. A tungsten beam was fired across the camera's field, replicating every Perseverance parameter. The streak appeared, yes, but the double flare refused to appear. Natural motion blur could not imitate what Mars had seen. By late October, 3 independent labs had performed their own reconstructions. All confirmed Loeb's model could make a line. None could make it shine the same way. Some whispered of microlensing, a brief glint of sunlight refracted through airborne dust. Others proposed internal reflection within the camera housing. Each idea explained part of the pattern and failed another. It was science performing its slow, beautiful dance with doubt. Then came the comparative geometry study. Analysts overlaid Perseverance's image with orbital telemetry from the Mars Reconnaissance Orbiter. The streak aligned almost perfectly with 3i, Atlas's inbound vector tilted 12.7 degrees west of north, the same direction predicted by celestial mechanics. If this was an artifact, it had chosen the exact path of the real object. Probability 1 in 5,000. You stand beside those monitors now. Your reflection shivers in the glass. Somewhere between coincidence and communication, the line between noise and intent begins to thin. Not proof, not yet, but a whisper of geometry in the void, as though something or someone understands angles the same way we do. The scientists made no claim of revelation. They published cautiously attached uncertainty bars, spoke in decimals and disclaimers. That is how truth travels slowly, foot by foot, across the red dust. But when each simulation ended and the servers cooled, the image lingered. A silver line suspended between equations, asking quietly whether the explanation had already become an assumption. Outside, Mars turned through its thin twilight, and the interstellar traveler drifted farther from view. Inside, the test results stacked neatly in digital archives. The numbers were calm, the hearts behind them were not. For every equation that closed another possibility opened a reminder that in science, solving a mystery is only ever the beginning of another. And when the simulations ended, the laboratories fell quiet. Screens blinked to black, fans slowed, keyboards clicked one last time. What lingered was not certainty, but a glow, faint, persistent, like the shimmer that remains after lightning when your eyes are closed. They called it the afterglow, a brightness that refused to vanish, even when every instrument had stopped recording. On the printed reports, everything was neat and clinical coordinates, exposure times, reflectivity curves, error margins. But between those columns of data, something unquantified remained, the sense that they had touched the boundary of knowing. 3 just. Atlas had already passed its path curving inward toward the sun, yet its image haunted every mind that had stared too long. Even Avi Loeb, ever the rationalist, admitted quietly. Science explains what happens, but it doesn't always explain why it chooses to happen this way. At night, some engineers stepped outside the control buildings. They looked up not at graphs, but at the real sky. Mars was invisible now, hidden beyond Earth's horizon. The traveler beyond it was long gone. Only the stars remained cold, steady, ancient. And for a moment, the distance between observation and wonder collapsed. Every photon that reaches us is already history. To look at the universe is to stare backward in time, to witness what no longer exists, yet refuses to be forgotten. You can feel it standing under that vast silence, realizing that everything bright is already gone and still it burns. The glow from 3i Atlas was no exception. The light recorded by Perseverance had left the object minutes before the camera ever opened its shutter. By the time we saw it, it was already a ghost of motion burned into silicon. And yet that ghost changed something. In Cambridge, Loeb wrote a small note in his personal log. The image reminds us that explanation and meaning are not identical. He did not mean faith, he meant humility. The awareness that precision and mystery are partners, not enemies. Among researchers, small debates persisted. Was it illusion, reflection, coincidence rehearsing itself for the imagination? But beneath those questions breathed a gentler realization that maybe the human need to ask is itself a form of light, a refusal of the darkness of indifference. A week later, as the official report circulated, one quiet paragraph stood out. The brightness gradient of the observed streak remains unexplained. Further investigation recommended. No headline printed it, but in the language of science, it was poetry, a confession that even inside precision wonder still has room to breathe. Now, imagine yourself there. The lights are low, outside the campus hums with late-night stillness. You hold the printout, a silver line across the Martian sky. You tilt the paper, and for an instant it catches the light. The streak gleams again, as if to remind you that mystery isn't meant to be solved, only sustained. 3i. Atlas has already moved on. Its orbit carries it inward between Mars and Jupiter, a brief wanderer before it slips back into interstellar dark. No more data, no more images, only the lingering question of what it was and what it meant to see it. So the scientists return to routine recalibrating, preparing for the next anomaly. But beneath their calm precision lies a quiet vow that when the next signal comes, when another fragment of the unknown crosses the thin blue edge of awareness, they will listen differently. Because every discovery leaves a resonance, every afterglow is a promise. Light once seen never truly disappears. It waits patient, unending in the mind long after the sky has gone dark. Long after the laboratories went dark, when the final report had already settled into digital storage, the next clue surfaced from somewhere far smaller, a backyard beneath a cold suburban sky. It began not with an array or a satellite, but with a person. A YouTuber who called himself Dobsonian Power, named for the 12-inch reflector he had built by hand in his garage. He was no credentialed scientist, but his dedication bordered on devotion. Every clear night since August, he aimed that handmade telescope toward the faint path of Three-Eye Atlas, following it like a heartbeat through the constellations. When the professional stopped receiving data, Dobsonian didn't. On October 5th, one night after NASA's feed had fallen silent, he captured a frame that would ripple across the world. Short exposure, less than a second. No automation, no image stacking, no tracking correction. And yet the result defied logic. The same elongated shape appeared again, cutting through the Martian sky like a blade of light. He posted it with a caption that read, "Only if it's a glitch, it's a persistent one." Within hours, the image spread. At first, astronomers dismissed it. Amateur optics, atmospheric distortion, uncontrolled variables. But when analysts inspected the raw metadata, the timestamp aligned precisely with the final reflectivity spike recorded by Mars Express. Different planet, same light, coincidence? Maybe. Yet science grows uneasy when coincidences begin to repeat. Imagine standing beside him that night. The air bites at your hands. The tracking motors hum softly. He leans over the telescope breath, fogging the eyepiece. Through the lens, a faint smear of brilliance trembles, too structured, too deliberate. He presses the shutter. The frame he captures will travel farther than his telescope ever could, challenging the silence of institutions. The image was crude, stars blurred at the corners, color balance drifting toward amber. But within that imperfection lay power proof that observation does not belong only to machines. The form was unmistakable, a narrow cylinder ratio nearly 4:1 tilted 45 degrees like a drawn blade of glass. No stacking, no algorithm, no composite. Just an instant that should have shown a dot and instead showed a line. Thinking his optics were dirty, Dobsonian disassembled the telescope. He cleaned the mirrors, the sensor, the focus assembly. Then he aimed again. Another frame. Another line. Whatever moved out there was not dust. It was consistent, alive in its precision. Soon professional astronomers noticed something stranger. Between nights, the angle of the streak changed, not its place, but its orientation, as though the object was slowly rotating on purpose. If true, it was not tumbling like rock. It was spinning, stable, deliberate. In the vocabulary of physics, that is a whisper of design, but design implies intent, and intent is dangerous territory. Dobsonian avoided the word entirely. He called it a curiosity. Still, you can hear the thrill under his voice in the live stream. I don't know what it is, but it doesn't behave like any comet I've tracked. In Cambridge, Avi Loeb read the post and smiled, half amusement, half recognition. He respected curiosity even when it challenged his equations. Requesting the raw files, he compared them against his models. Mathematically, elongation could still be explained, but rotation could not. For the first time since the blackout, uncertainty felt alive again. If science is a dialogue, this was its reply, not from a government lab, but from one person's persistence. The cosmos had grown smaller, more intimate, a telescope in a backyard continuing a mission that had gone silent millions of kilometers away. Every discovery attracts its shadow. The brighter the light, the sharper the doubt. Skepticism came quickly, it always does. Every discovery must pass through the furnace of doubt before it can stand on its own. The first counter-argument formed almost instantly: dust. A tiny grain on the mirror, a smudge on the lens. Nothing cosmic, just the oldest illusion in astronomy. It was a reasonable claim. Dust has fooled even the most seasoned astronomers. It makes false stars, bends, halos, turns streaks into ghosts. Dobsonian knew that better than anyone. His telescope had stared through enough desert nights to earn its caution, and yet the image refused to fade, not from his screen nor from his mind. The next evening he began the ritual of verification. Slow, methodical. He disassembled the entire telescope by hand mirror, removed sensor cleaned with isopropyl swabs, housing sealed tight alignment rechecked by a narrow red laser. He rebuilt it under the same patch of sky, same coordinates, same temperature, same depth of focus. The night was clear, humidity low, no dust storms on the Martian forecast feed. He aimed again. This time he stayed live on stream, a dozen viewers listening to his quiet voice through the hum of tracking motors. "If this is just dirt," he said, "we'll know tonight." The shutter clicked. A faint point blinked onto the screen, then sharpened. The same silver line, thin as a thought, carved across the frame. Dobsonian leaned back, stunned. Whatever it was, it had survived the cleaning. He posted the new image and the debate reignited like static across the web. Some claimed it was atmospheric reflection, a satellite glint refracted through thin Martian air. But that theory failed on contact. His telescope wasn't aimed at Earth's sky, but at NASA's live relay feed from the rover's Horizon overlay. Every coordinate matched the original data grid. This wasn't weather. This was alignment. Optical engineers joined the fray. They analyzed the pixel distribution, looking for the scatter pattern of dust on glass. There was none. If a particle had clung to the sensor, its position would have shifted as the telescope moved. Instead, the streak aligned perfectly with 3i, Atlas's known trajectory for 2 consecutive nights. That precision troubled even the skeptics. A dust mote does not obey celestial mechanics. Still, disbelief has layers. A second theory rose: internal reflection. Perhaps the mirror's curvature was ghosting light inside the tube. Dobsonian tested that too. He swapped in an older primary mirror, recalibrated collimation, reset the mount. He took another frame. The same line appeared, the same ratio, the same metallic shimmer. But this time something new followed it. A faint glow trailed the streak, a fan-shaped blur like the tail of a stingray. He increased contrast. The fan brightened. Its direction pointed toward the sun, not away from it. A comet's tail never behaves that way. Light was doing something no model could explain. When he uploaded the frame, the online world erupted: amateurs, professionals, skeptics, believers, arguing beneath the same digital sky. Some accused him of fabrication. Others began to build trajectory simulations, testing every angle, every hypothesis. None fit cleanly. Every explanation solved one anomaly and created another. Imagine watching the discussion unfold, post after post, graphs, equations, midnight speculation. Between each message thread, you can feel something deeply human: the refusal to settle. We build telescopes not to confirm what we know, but to find the places where we might be wrong. And here, in the grainy light of a homemade lens, wrongness shimmered with its own kind of beauty. Dobsonian avoided conclusion. He simply wrote in his nightly log: same result. Clean lens, same rotation. Possible tail feature. That single line travelled into forums, Slack channels, research inboxes. Within days, Loeb's team requested the raw data again, this time, measuring the angular drift between frames. The numbers were small but undeniable. The object's axis had rotated 5 degrees between captures. Not random tumble, controlled turn. Torque implies structure. And so, the dust theory, the simplest, most comforting answer, collapsed under the weight of its own precision. What remained was a question wrapped in light, if not dust. Then what? That is movement. The simplest test of life and the hardest to interpret. When Dobsonian set his 2 clean frames side by side, he expected twin streaks, lifeless lines of light on the same vector. Instead, he saw a subtle tilt. 5 degrees, enough to notice, too precise to dismiss. At first he blamed calibration. Telescopes drift, Earth spins. A minor tracking offset can make any distant body appear to shift. But this wasn't ordinary drift. Both images were locked to fixed background stars, and those stars remained perfectly still. Only the streak had turned, as though the object itself had adjusted its posture mid-flight. He combed through the metadata: timestamps, azimuth, altitude, exposure, focus, depth, flawless. Same instrument, same position, same weather. Everything matched except the angle of the light. It wasn't random. It looked deliberate. The next night he aimed again, hoping the anomaly would collapse under repetition. It didn't. The line appeared once more, now 8 degrees from its original orientation. If it were tumbling like a comet, the rotation would have been chaotic. Instead, it was smooth, predictable, a slow turn like a compass needle finding north. He sent the images to Loeb's team, attaching no speculation, only numbers. Hours later, the reply arrived. Confirmed rotational variance, possible torque event, recheck exposure timing. They ran simulations. None of the models fit. No orbital perturbation, no solar radiation pressure, no magnetic drag produced a pattern that elegant. The object appeared to be controlling its spin. That word controlling hung in the air like static. It broke the first rule of neutrality. To say something is controlled is to hint at intent, and intent implies agency. No one wanted to cross that threshold. Loeb approached it carefully. He noted that natural torque could occur if jets of gas vented asymmetrically, a process seen in active comets. But 3SME Atlas showed no signs of venting. Its thermal profile, confirmed by both Mars Express and Earth-based infrared arrays, revealed no plume, no tail, no outgassing, and still it turned. Imagine that moment, a collection of the planet's sharpest minds staring at a single equation that refused to balance. The data said movement. Physics said no cause. Something was turning the traveller and no one could say why. Dobsonian's newest frames added another clue. As the object rotated, its reflection pattern changed, the leading edge brightened, the trailing side dimmed, then reversed. To anyone familiar with satellites, the pattern was hauntingly familiar. It was the kind of specular flash sunlight makes on flat surfaces like solar panels slowly catching dawn. He said nothing to the public. He only typed into his notes, object possibly rotating on fixed axis. Rotation interval 36 hours. That number caught Loeb's eye. 36 hours was too slow for a natural spin at that scale. A 1,000-meter object rotating freely would tumble chaotically unless stabilized by internal mass distribution. Stability meant control, and control implied structure. Speculation began to whisper through private channels. Could this be a fragment, a relic drifting between stars, a derelict probe, the ghost of a civilization long extinguished? Most dismissed it out of caution. But even the skeptics couldn't ignore the rotation data. A comet that doesn't vent and still turns is a paradox wrapped in light. Dobsonian felt none of the grandeur others projected. He was tired, grounded, a little afraid. He stared at the newest frame, a bar of silver against Martian red, and whispered toward the screen, "If you're just a rock, you're a very disciplined one." Outside, the night held its breath. Mars spun unseen beyond the clouds, its dust storm sleeping. Somewhere near its orbit, a silent traveller turned slowly, rhythmically, its motion, neither chaotic nor random, like a pendulum, counting time in a universe too vast to hear it. Movement became pattern, pattern became question, and question needs answer. If rotation persists, we need to redefine the category. The sentence left Loeb's office at midnight, a single pulse of light through fiber optic cable. It was the nearest any scientist had come to admitting the unthinkable. For weeks, 3i Atlas had behaved like an equation that refused symmetry, every variable elegant, every constant slightly wrong. Now faced with persistent rotation and mirrored reflections, the familiar explanations began to fracture like old glass. At the next meeting, Loeb stood before a wall of trajectories. Each curve on the screen glowed in a different color: gas venting, radiation, torque, magnetic drag. Every model failed. He tapped the display once, the simulation spun in silence. Nature, he said, doesn't often build this kind of balance. No one answered. Around him, colleagues pretended to scroll through data. The hum of the projectors filled the room, the same tone that had accompanied every scientific revolution, before anyone realized it was happening. Dobsonian joined remotely, his webcam flickering his garage laboratory, forming a constellation of shadows behind him. He spoke quietly, voice rough with fatigue and wonder. "It's not moving randomly," he said. "It's turning with intention." Maybe not intelligent intention, but intention nonetheless. The word hung like voltage between circuits. Intention, a forbidden term in physics. To say it aloud is to step outside the safety of forces and enter the terrain of meaning. Science can describe how something turns. It hesitates to ask why. They tried to stay within numbers. Graphs appeared, torque coefficients, mass distributions, reflectivity curves. Equations explained everything except the reason the equations had to exist. For every proof, a counterexample. For every simplification, the data pushed back. Outside the labs, the story escaped. Online forums filled with conjecture videos comparing 3i Atlas to metallic sky chariot's animations, looping its measured rotation like a mechanical prayer wheel. NASA declined comment. The government shutdown persisted. Silence only fueled imagination. Yet in private curiosity thrived. One morning, Loeb received an anonymous file, a cleaned composite of Dobsonian's newest frames, AI-enhanced deblurred. When he opened it, the cylinder resolved into something more complex, a long central body, faint ridges, a narrow fin trailing behind a geometry that suggested disturbingly design. He refused to speculate aloud. Instead, he ran photometric analysis, mapping brightness along the hull. The pattern repeated in intervals too regular for natural roughness, as if light were tracing panels, smooth, reflective bands aligned like the plating of a vessel. He called to his assistant. Compare it to known rotation models. The computer worked for hours, spinning millions of permutations. None fit perfectly, but several matched old human satellites, derelict relics from the early space age. Proportionate, engineered, intentional. Still he hesitated. In science, hesitation is not weakness, it is integrity. He wrote carefully, each phrase balanced like a bridge. Observed rotational pattern may result from non-random mass distribution. A sentence that said nothing and implied everything. Meanwhile, Dobsonian felt the shift long before it was spoken. His inbox overflowed, journalists, skeptics, dreamers. Some called him a fraud, others a prophet. He ignored them all. Night after night, he returned to the telescope, chasing the turning light. It was no longer data, it was conversation. That evening, beneath the hiss of wind and motor, he spoke softly to his stream. We always talk about evidence. But sometimes what keeps you awake isn't the evidence, it's the thought that the universe might be trying to tell you something, and you're the only one still listening. He smiled, half apology, half faith, and pressed record. Back in Cambridge, Loeb scrolled through the Mars Express telemetry again. There it was, a faint periodic fluctuation in radio brightness every 36 hours, a soft pulse in reflected energy perfectly synchronized with Dobsonian's rotation data. Coincidence again, or the first rhythm of alignment, light and motion breathing in the same tempo? No one claimed discovery. No one claimed miracle. They simply stared at the graphs, aware they were witnessing the erosion of certainty, that delicate instant when explanation ends and comprehension begins. Later, the rotation data would be archived under unresolved mechanical anomaly, a phrase sterile enough to preserve funding, gentle enough to cradle mystery. But for those who had watched the light turn pixel by pixel, night after night, the label meant nothing. They had seen an object move not only through space, but through understanding itself. And in that slow revolution, humanity caught its reflection. We too revolve endlessly around what we cannot explain, drawn by gravity, held by hope. Chasing the thin light that refuses to stay still, certainty cracked like glass. And in its shards, 7 questions began to glow, each one a point of light, not yet a conclusion, but a direction. Loeb called them the 7 anomalies. The phrase sounded poetic, but in truth it was a catalogue of contradictions, precise, measurable, and impossible to reconcile with the ordinary behaviour of comets. He began, as science always must, with what can be measured: size, reflectivity, density, motion. Each metric told a story that didn't belong to the solar system's script. According to high-resolution estimates from Mars Express and Earth-based radar 3i, Atlas stretched nearly the length of Manhattan, 10 kilometers long, perhaps more, with a mass approaching 30 billion tons. That alone was absurd. Interstellar visitors like Oumuamua and Borisov had been fragile, fleeting things. This was a leviathan among wanderers. Statistically, such a mass should have shattered under tidal stress during entry. It didn't. Something in its composition resisted fragmentation, as though the object understood tension and refused to break. Spectrographic readings revealed unusually uniform albedo. Natural comets shimmer with mottled light dust, ice rock chaos. But this one reflected evenly, every point the same. Not polished like chrome, but consistent, engineered, deliberate. Loeb wrote in his notes, homogeneity in albedo, unlikely under stochastic formation models. In simpler words, nature doesn't do smooth without help. When sunlight touched the object, no thermal lag appeared. No jets, no outgassing, no plumes. Infrared data from the European and Indian telescopes showed perfect equilibrium, as if the surface conducted heat like metal, not stone. It didn't breathe like a comet. It regulated like a mechanism. Colleagues proposed a cautious comfort, maybe a nickel coating masking temperature gradients. Loeb accepted the math, but not the peace it offered. Nickel, yes, but no iron. Spectroscopy showed the absence of Phaeer heresy in stellar chemistry. Nickel and iron are twins born from the same cosmic furnaces. To find one without the other was like finding a melody missing its harmony. He circled the reading twice Ni without Phae non-standard composition. Under polarized filters, natural bodies scatter light at random. 3i. Atlas held a steady polarization angle of 14 dm, repeating each rotation like a metronome. Stable, rhythmic, as if light were reflecting from flat surfaces rotating in sequence. Someone joked it looked like solar panels breathing sunlight. No one laughed. Even without visible propulsion, the object's trajectory traced almost perfectly along the ecliptic plane, the thin disk where our planets dance. Most interstellar visitors cut through that plane at wild inclinations. This one joined it, syncing to our system's rhythm as if hearing a song and falling into step. Loeb's assistant whispered half to himself, "It moves as if it wants to belong here." He didn't mean it literally, but the phrasing lingered like static in the air. A faint emission trail appeared barely measurable, pointing toward the sun, not away. Comets exhale outward under heat. This one seemed to inhale. It broke the logic of evaporation itself. Loeb wrote it plainly. Observed vapor trajectory inconsistent with solar vector. Investigation required. But in private he admitted what everyone else had begun to feel: this wasn't rebellion. It was design. Imagine standing in that Cambridge lab. The screens glow pale blue. Equations ripple across the air like tides. Every variable fixed creates another fracture. Increase density to explain spin and the mass becomes impossible. Decrease reflectivity to match dust and the thermal data collapses. Every answer births a contradiction. And so anomaly became architecture, 7 pillars of uncertainty, holding up a structure made of doubt. Beyond physics, a subtler pattern emerged: behavioral order. Even without thrust. 3i, Atlas, followed a path that felt choreographed, a gesture of belonging, a rhythm we could not translate. When the session ended, Loeb walked alone across the Cambridge courtyard. Clouds erased the stars, but in his mind the object kept turning, its edges gleaming like a thought refusing to fade. Each contradiction glowed not as failure, but as a mirror reflecting humanity's fear of reaching the end of explanation. And so in the quiet before dawn he wrote one final line: "The universe is not obligated to behave as we expect, but neither is it prohibited from astonishing us." It was confession and prophecy at once, the acknowledgement that certainty had splintered, and through those fractures something luminous was beginning to emerge. Every mystery eventually turns inward, from movement to matter, from what it does to what it's made of. If rotation hinted at intent, composition whispered something deeper: memory written in metal. The previous session had ended with equations of mass and motion. Now the discussion turned inward to substance, to the thing itself. If its motion defied gravity, its chemistry defied history. Loeb began with spectra, long ribbons of light gathered from observatories in Chile, Hawaii, and orbit. Each one sang the same strange refrain: strong nickel signatures, weak to no iron. That single line was enough to fracture an entire chapter of cosmic metallurgy. In the periodic table of stars, nickel and iron are twins, forged together in the collapse of suns cooled side by side in the ashes of supernova. To separate them is to rewrite the recipe of the universe. Every meteorite, every comet we've ever touched carries both, always both. And yet 3i Atlas broke the rule. Loeb stared at the emission graph, voice almost a whisper. "Nickel without iron," he said. "It's like tasting salt without sodium." No one spoke. Some suspected contamination, Mars' thin atmosphere, instrumental interference calibration noise. But cross-checks from independent telescopes confirmed it. The Ni-Phae ratio was thousands of times higher than expected. It wasn't an error. It was an identity. Imagine the scene: a long conference table printouts glowing under sterile fluorescent light. Each spectral curve rises and falls like a voice trying to confess. To the untrained eye, the lines look trivial, minor peaks, subtle valleys. But to a physicist, those peaks are syllables in the language of matter, and this object was speaking in a dialect no one had heard before. Nickel, Loeb knew, is not just reflective, It's resilient. It resists corrosion, endures heat channels, magnetism like thought through wire. If someone wanted to build something to survive interstellar travel to last for thousands of years between suns, nickel would be the perfect choice. But even thinking that felt dangerous to cross from data into design. So they searched for safer explanations. Could 3I's Atlas have formed in a nickel-rich, iron-poor nebula, a stellar nursery frozen before equilibrium? The model said maybe rare, short-lived, improbable. A geological orphan cast into darkness born from a star that broke symmetry and never healed. But the mystery thickened. High-energy spectra revealed traces of sulfur compounds bonded with nickel crystalline stable, unnaturally pure. Such materials form only under pressure and precision, intense heat, rapid cooling, and the absence of oxygen. Conditions not of space, but of furnaces. Loeb circled the data in red ink. Industrial profile. He didn't say it aloud. He preferred the safer phrase non-natural bonding sequence. But everyone in the room felt the gravity of that implication. Something had arranged these elements with purpose. Outside, the evening light thinned across the Cambridge windows. Dust motes drifted, catching the glow of the monitors, tiny worlds orbiting in silence. It was easy to forget that these numbers described something millions of kilometers away, a traveler built of silence and reflection. Loeb leaned back, chair creaking softly. We might be seeing the fingerprint of an environment, he said, not a machine. Think of it as geology without a planet, a distillation of matter near a dying star. A student lifted her hand. Then what explains the purity, she asked. Nickel. This clean shouldn't exist naturally. He paused, weighed every possible escape route in his mind, and answered with the only honest words science allows when it reaches its horizon. We don't know. Yet. He turned back to the data. The spectral line of nickel pulsed softly on the screen like a heartbeat that refused extinction. Somewhere within that pulse lay a memory of heat collapse endurance. Maybe it was just mineral perfection, or maybe it was something made to last beyond time. Outside the lab, speculation spread like static over an old radio. Some called 3I, Atlas the alloy comet, others the silent ship. None of the names fit. They weren't meant to. Names are what we invent when certainty dies. Meanwhile, Dobsonian kept watching. Each night his telescope caught a faint fluctuation, brightness rising and falling, every 36 hours, the same rhythm as its rotation. Perhaps sunlight glinting on layered metal. Perhaps memory reflected in motion. If chemistry is the fingerprint of origin, orbit is the handwriting of intent. Matter can tell us what something is, but trajectory hints at why it moves at all. For most wanderers that slip into our solar system, motion is chaos, random, reckless, like arrows loosed from a night that never learned aim. But when Loeb plotted the path of 3I's Atlas, the curve that bloomed across his screen was not chaos, it was choreography. He watched the orbit unfurl a line, bending with improbable grace, threading between planets as if the cosmos itself were writing cursive. The object didn't just cross the ecliptic plane, it aligned with it within half a degree. Oumuamua and Borisov had sliced through that plane like strangers. This one moved as if it recognized the dance floor. You can almost see Loeb standing there, his reflection ghosted in the dark glass of the simulation. The line of orbit glows faintly against a backdrop of planets, each ellipse a luminous pulse of motion and mathematics. An interstellar traveler behaving like a local, he murmurs. That shouldn't happen. At first he suspected bias, bad data, bad math, a human mistake pretending to be cosmic pattern. But every recalculation returned the same impossible symmetry. Mars, Jupiter, Venus. Each encounter arranged like a sequence of careful steps, as if the object used gravitational assist the way we use words to move with intention. Voyager had done it. Cassini had done it. New Horizons had done it. But those were machines' deliberate emissaries built to talk to gravity. 3I, Atlas was not supposed to know the language, and yet it spoke fluently. Loeb called the trajectory unnervingly articulate. In a draft that would never make it to print, he wrote, "It behaves as though negotiating with the planets." No one dared quote that line publicly, but in quiet corridors it passed from mouth to mouth like rumour wrapped in reverence. When plotted backward, the orbit traced not to randomness, but to the direction of Sagittarius A, the galactic core, a region of magnetic storms and radio noise, a place from which nothing stable should ever emerge intact. And yet here was this traveller cold serene, its path carved like calligraphy across our ordered sky. Imagine standing beside Loeb in that room. The air hums with the static breath of servers. On the projection wall, planets drift through luminous ellipses, their light spilling over his hands. You can almost feel the rhythm gravity as pulse orbit as metronome. Meanwhile, far from Cambridge, Dobsonian built his own simulation in a garage filled with dust and starlight. He uploaded a video titled The Line That Shouldn't Exist. In it, he zoomed out from Mars until the planets looked like pearls strung on invisible wire. Through them, Atlas threaded perfectly like a needle, guiding light through a cosmic loom. Comments flooded in, "It's surfing gravity. No way that's random. Whoever built it knows orbital math." But Loeb resisted the comfort of myth. He told his students, "Probability is not causality. The universe owes us data, not intention." Yet his tone softened because sometimes data feels like voice. As the analysis deepened, one coincidence turned surgical. At Periastron, the point of closest approach to the Sun, 3I, Atlas brushed Mars within hours of its closest pass. Had it arrived even a week earlier or later, no camera would have seen it. Instead, every active sensor, high-rise Mars Express Perseverance, was in perfect position, as though the sky had arranged its instruments to greet a guest. A scientist from ESA whispered half-joking, "It's like it wanted to be photographed." But no one laughed anymore. Then came the final alignment, its outbound trajectory aimed almost exactly toward the coordinates of the 1977 WOW signal. The match within a single degree. Coincidence, perhaps, or choreography at cosmic scale. Loeb's final note from that night was simple, almost human. If not guided, it is an accident of staggering beauty. You and I can imagine that moment, the lab gone quiet. Monitors dimming planets gliding through their arcs, like dancers on invisible rails. The orbit of Thresus Atlas curves across the simulation, turning gravity into syntax, each slingshot, a syllable, each alignment a pause. And standing there, you feel it too, the sense that physics might just be another way the universe learns to speak. Every orbit leaves a trace, a curve through space, a signature against the dark. Some signatures end in silence, others continue into memory. And sometimes what we call coincidence is simply the universe rhyming with itself. The line that left Mars' orbit curved outward, bending through the dark like a whisper drawn across a page too vast to read. When extended, that trajectory crossed a small patch of sky, a region humanity had once named not by certainty, but by a question: Sagittarius. Where almost 50 years earlier, a telescope in Ohio had heard a sound the universe never repeated. August 15th, 1977. A narrow band burst 72 seconds long, pure surgical perfect. Its frequency, a 1420 megahertz. The hydrogen line, the universal syllable of existence. Astronomer Jerry Eman, caught between disbelief and awe, circled it on paper and wrote one word: "Wow." The name endured. The signal never did. For half a century it waited in silence, an unfinished sentence written in hydrogen and hope. Now, Atlas was writing in the same direction. When Loeb overlaid the object's path on the coordinates of that old detection, the room fell into involuntary stillness. On the projection wall, a thin red line, the orbit brushed a white circle marking the WOW signal's origin. The intersection angle, 0.8 degrees, too close for comfort, too poetic for probability. Someone whispered, "That can't be coincidence." Loeb didn't look up. "Then it must be," he said softly. Until proven otherwise. He zoomed in further. Two timelines separated by decades met on a digital sky. A sound and a trajectory, a voice and an echo. To a statistician it meant nothing. But even the mathematicians felt it, that quiet pull where science touches story. The discussion drifted toward physics. Could solar radiation or asymmetric reflection or solar wind drag nudge an object so precisely? Yes, theoretically. But physics scatters. It does not aim, only guidance converges. For comparison, Loeb plotted Oumuamua and Borisov across the same coordinate frame. Their paths diverged like stray thoughts. Only 3I Atlas curved toward the memory of a signal, as if remembering a sound it had once heard. He cross-checked with archives. No satellites, no debris, no modern transmission on that vector. The path was clean, unnervingly clean. Purity can be as unsettling as chaos. Word spread quietly through Cambridge. Emails traded phrases like secrets, vector towards Sagittarius confirmed, same coordinates as WOW in midnight group chats. Researchers began calling it half-jokingly the reply. Meanwhile, in a garage under a suburban sky, Dobsonian ran his own simulation. The glow of his monitor painted his hands pale blue. He watched the orbit stretch through the constellations and whispered to his small online audience, "It's heading home." The chat window filled with emojis, disbelief and silence. He wasn't making a claim. He was naming a feeling, that strange resonance between a sound once heard and a light now seen. Back in Cambridge, Loeb held his skepticism like a compass. Correlation isn't causation, he reminded his students. The cosmos loves patterns that mean nothing. But later, softer, he added, if that signal was a broadcast and this is a vessel, it would be the most patient reply in history. No one laughed. No one dared to. He reopened the 1977 printout Hydrogen's voice captured in black ink. 1420 megahertz, the one frequency every civilization would recognize. If someone wanted to say we are here, that's the frequency they would choose. Now, almost 50 years later, a silent traveller curved through that same patch of sky, as if finishing the sentence we never understood. Outside, the October wind rattled the windows. Leaves turned slowly in the campus lights, the same wind that had brushed the dishes of the Big Ear telescope long ago. Time had folded on itself, two messages separated by half a century, linked not by technology, but by wonder. Loeb walked to the window. In the glass, his computer screen reflected a second sky data points floating like stars. He thought of coincidence and of the human need to turn geometry into meaning. Maybe the path meant nothing. Maybe it meant everything. Maybe the universe had been speaking in coordinates all along, and we were only now learning how to listen. He returned to his desk, typed a final note. Trajectory towards Sagittarius confirmed. No anomalous acceleration. Alignment statistically negligible. Emotionally profound. He smiled at the paradox. No journal would publish a line like that. But it was the truest sentence he'd ever written. As the simulation rendered its final frame 3E, Atlas appeared as a faint spark moving into the dark, a traveller following the memory of a sound. While telescopes traced the heavens, other eyes quieter hidden traced the silence below. Not every observer looked up. Some listened through cables and cold air in rooms where screens glowed like small suns, and the wind outside was replaced by the hum of machines. It was there in the folds of bureaucracy that another kind of story began to surface, one not of stars but of secrets. Congressman Tim Burchett had never planned to become a messenger for the extraordinary. He was a man of plain words and long pauses, a politician who preferred the ground to the sky. But over the past year, his name had begun appearing beside acronyms that sounded like riddles. UAP, USO, Anomaly, each one a door half open, half denied. When reporters asked, he leaned forward as if the microphones themselves might be listening too closely. "They're real," he said once, "and the government knows more than it admits." The quote crackled through news cycles like static. To some it was performance, to others it was fatigue, the sound of someone who had looked too long into classified dark. In private briefings, Burchett had been shown footage that made the air in the room go still. Objects the size of stadiums plunging from the sky into the ocean without splash, accelerating underwater faster than torpedoes. To physicists, that data broke hydrodynamic law. To politicians, it broke silence. He began connecting dots in public hearings, threading together names and patterns that bureaucracies preferred to keep apart. And one of those names was Avi Loeb. "Loeb's doing it right," Burchett said. "He's testing, not speculating. That's what we need, less secrecy, more measurement." The words were calm, but in government corridors they landed like flares. For decades, whispers about aerial and submersible phenomena had been buried in the margins of defense reports. Now the same language, metallic composition, anomalous acceleration, non-random trajectory was showing up in documents stamped top secret. As though two mysteries, one in orbit and one beneath the sea, were beginning to share the same shape. The parallels multiplied. The object that descended toward Mars and the ones that descended beneath our waves. Nickel without iron. Structures that resisted impossible pressure. Geometry repeating itself in two domains that were never meant to meet. If those reports were true, then the boundary between interstellar and terrestrial unknowns had thinned as if space itself had begun to echo underwater. Imagine the scene: a congressional room half lit by projectors, footage playing in slow motion, a bright sphere plunging into black water, leaving no ripple, no foam, only absence. A laser pointer circles the blur. Someone clears their throat. No one says the word alien. They don't have to. The word hangs in the air like humidity. For Loeb, this sudden political gravity was both gift and curse. Attention meant funding new telescopes, new missions, but attention also meant distortion. He once told a colleague, "The moment you say intelligent science becomes suspicion." And yet here they were, the scientist and the politician, orbiting the same truth from opposite directions. Not debating if anomalies existed, but why they multiplied the moment we tried to define them. From telescopes to submarines, from classified sensors to backyard cameras, a strange convergence began to form. Different instruments, same pattern. Different depths, same shimmer. It was as though the universe had decided to test every domain at once, sky, sea, and human mind alike. Somewhere inside that convergence, the line between secrecy and discovery began to blur. Governments were learning to keep silence the way the stars had, not as denial, but as language. And while the cosmos turned overhead, the hum of servers continued below, steady, patient, unblinking, as if Earth itself had begun to listen back. Silence travels strangely. It can rise like light or sink like stone. If the sky could hide visitors, then the oceans, vast, opaque, unlit, could hide civilizations. It was not a new idea, but beneath the grey glow of leaked intelligence reports, it no longer sounded like fiction. It sounded like logistics. It began with a single sentence from Congressman Tim Burchett, spoken offhand, and repeated until it felt like revelation. "We know more about the surface of the moon than we do about the floor of our own oceans." A simple fact sharpened by context. If 3i Atlas represented the interstellar unknown, then perhaps the deep ocean was its mirror, a version of mystery turned inward, hidden not by distance but by depth. After the declassification of Navy UAP reports, a new vocabulary began to circulate: fast movers, transmedium craft, USOs. Radar operators described objects diving from air to water, without splash, without shockwave, changing medium as easily as light passing through glass. Hydrodynamics said impossible. Sensors said recorded. Loeb had read the reports, though he refused to let wonder outrun proof. Chase data, not folklore, he would say. But even he admitted that the ocean, with its pressure and silence, was the most natural hiding place in the solar system, electromagnetically quiet, stable, and invisible to almost every human instrument. In a private memo he once wrote, "If another intelligence wished to observe us discreetly, the ocean would serve as the perfect lens." He meant it hypothetically. Others did not. Soon the phrase deep water theory began to appear, half metaphor, half accusation. A proposal that perhaps remnants of interstellar probes or technologies older than our civilization might rest at the bottom of Earth's trenches. To some in Congress, these were alien bases. To scientists, speculative infrastructure. To both, they were an invitation. Imagine yourself standing at the edge of the Mariana Trench. The sea stretches black and calm, but 11 kilometers below, the pressure rises 1,000-fold. Steel folds like paper. Sound bends and refuses to return. Light dissolves into chemical night. Yet sonar sometimes reports movement, metallic, deliberate, trailing echoes that hum like the voice of a cathedral forgotten by time. The Navy calls them noise. The curious call them reminders. One declassified report from 2019 described an event near Guam. An unidentified submerged object tracked for 3 minutes. It accelerated from 30 knots to over 100 in under 5 seconds, a feat no human vessel could survive. Engineers reviewed the data. No glitch, no interference, no storm. Just a signature that refused explanation. The sea, it seemed, had learned how to keep its own secrets. To connect that incident to 3i Atlas would be reckless. And yet the symmetry was irresistible. The sky visitor defying the logic of orbit. The sea visitor defying the drag of water. 2 domains, one behavior motion without permission. Philosophers began calling it the dual abyss hypothesis, that intelligence might not live in a single world or form, but unfold as mirrors distributed across environments, echoing each other in silence. After all, both the cosmos and the ocean share the same grammar pressure, darkness, endurance. Both are places where life learns to persist unseen. Beneath the calm of official reports lies another ocean, one made not of salt but data. Thousands of terabytes sealed behind classification firewalls, their existence admitted only in redacted footnotes and slips of the tongue. If 3i Atlas was a mystery seen by telescopes, these were mysteries heard by sonar. It began quietly, as most revelations do. A small group of analysts reviewing 2019-2020 sonar archives noticed something strange: echoes that refused to behave like submarines, whales, or earthquakes. They moved too fast. They curved instead of scattered. Their Doppler shifts were clean, coherent patterns, belonging not to chaos but to control. Each event was logged, time-stamped, encrypted, filed. None were released. Not because anyone disbelieved, but because no one understood. And in the quiet machinery of intelligence, confusion is dangerous. It can look like weakness. So silence became policy. One case rose above the rest, the USS Omaha off the coast of California. Radar caught a bright sphere dancing erratically through clouds, then plunging straight into the ocean without splash. Below, sonar caught its echo, a single contact moving through water at 200 knots, then vanishing. The footage leaked months later, grainy, raw, undeniable, and still classified. Avi Loeb watched the clips from his Cambridge office, the blue light of his monitor reflecting in his glasses like a second ocean. He wrote one line. The difference between mystery and myth is measurement. He asked for the raw data: pressure curves, descent angles, acoustic resonance. The Navy refused. To them, he was an outsider. To him, secrecy was a kind of gravity-bending curiosity into silence. Yet privately, he was intrigued. The motion reminded him of something he'd seen before. 3i Atlas decelerating near Mars, pivoting without propulsion. Different worlds, same defiance. If the pattern held between sky and sea, then the law being broken wasn't atmospheric, it was universal. Imagine sitting inside the sonar room. The air hums with ventilation. Screens flicker with thin blue lines that shimmer like veins of light under skin. Every sound, every ripple catalogued ships, whales, storms. Then a streak. No cavitation, no turbulence, just a clean, straight trace sliding through black water faster than equations allow. The operator freezes. The computer does not. It records patient and indifferent. Later, some of those operators spoke anonymously. One described an object rising from the sea, dripping light instead of water. Another said it didn't push the air aside, it folded it. Metaphor, perhaps, or the vocabulary of shock trying to describe physics unprepared to exist. By 2023, the All-Domain Anomaly Resolution Office, ARRO, began stitching patterns. Air-sea orbit all domains one table. Cross-reference coordinates revealed synchrony objects appearing above and below within seconds, as though passing between elements with deliberate ease. One phenomenon, two faces. Loeb saw the symmetry immediately. 3i Atlas had done the same, falling from interstellar velocity into a gentle planetary hover. He didn't claim connection, only resonance. Different domains, same behavior, same silence. To the Navy, it was threat assessment. To Loeb, it was philosophy. What happens when motion itself begins to look like intention? When nature behaves as though it's aware of being watched? Official statements stayed predictable. No conclusive evidence of non-human technology. But deep in the archives, the data kept breathing: timestamps, depths, accelerations, a hidden library of impossibilities waiting for translation. And so, like astronomers watching 3i Atlas fade into the dark beyond Mars, the Navy's analysts kept listening. Their instruments pressed to the deep, their screens alive with quiet storms of meaning. They waited not for proof, but for the moment when noise would decide to speak. Patterns like tides always return. What began as scattered signals, sonar telemetry orbit now curved toward each other, as though reflection itself were learning how to think. The deeper the data reached, the more it began to resemble a mirror. The same geometries appeared again and again in the sky and the sea and the silence between. Acceleration without propulsion, light without source, motion without noise. Coincidence, some said. Symmetry, others whispered. Whatever it was, it looked like the universe repeating its own handwriting. Avi Loeb often said that science was not a wall but a bridge, a structure built between what we know and what we are still afraid to imagine. After the Navy's revelations, that bridge stretched farther than ever. The ocean, once the province of biology and geology, had begun to echo the riddles of interstellar space. Two unknowns separated by medium, united by behavior. He called it the continuum hypothesis. The idea that the cosmos does not truly distinguish between vacuum and water, that intelligence, if it exists beyond us, might move through both as easily as breath moves through lungs. Pressure and gravity, density and silence, different dialects of the same language. Late one evening, Burchett's staff called him. Another leak. A foreign navy somewhere in the Pacific had tracked an underwater contact, rising cleanly into the air, accelerating toward orbit before vanishing into static. No statement followed, but the pattern grew another point. A reflection, one hemisphere mirroring the other, as if sea and space were performing the same choreography at opposite scales. Loeb didn't endorse the story, but he couldn't ignore the symmetry. If the same laws held beneath and above, perhaps the same entities, or at least the same mechanisms, could cross between them. Not visitors from elsewhere, but messengers between mediums. A natural intelligence, an ancient machine. It didn't matter yet. What mattered was that the question had evolved. Imagine standing at the shoreline at dusk. The air is still. The water darkens until it becomes sky. You can't tell where one ends and the other begins. For a moment you feel the symmetry Loeb's data hinted at, that quiet illusion that the universe above and the universe below might be the same reflection seen twice. Burchett, in a speech few remembered but none forgot, said it this way: if they're watching, they're not just out there, they're in here too. The ocean, the atmosphere, the space between atoms. Maybe it's all the same neighborhood. His words weren't policy, they were reverence. A glimpse of what happens when politics looks too long into wonder. By then, the narrative had divided into two mirrors, the scientist staring upward through data and the politician peering downward through secrecy. But their questions began to rhyme, not what are they, but why do they echo each other? And beyond that rhyme, something deeper began to emerge, a sense that observation itself carries memory. Every sonar ping, every telescope frame, every orbital vector, they weren't just measurements. They were footprints of a pattern larger than human comprehension, hints of choreography stretching across environments and scales. Imagine following that thread from the faint glimmer above Mars to the streaks of light Dobsonia captured in his backyard, to the silent arcs moving beneath the Pacific waves. It's impossible to know where the signal ends and the interpretation begins. Perhaps that is the lesson: the universe does not separate the domains of observation, it unites them. Sky and sea vacuum and water data and doubt all echo the same fundamental rhythm. You could almost see it as a single intelligence or a single mechanism, moving across mediums, testing limits, tracing the invisible architecture of our world and others. And yet, just as we begin to map it, it shifts always one step beyond a reflection that teaches more than it reveals. Standing there beside Loeb or Burchett, you realize the true experiment is patience. The act of watching itself becomes proof, the courage to hold wonder without closure. And when you close your eyes, you carry the reflection with you. The universe is speaking, but not in answers, in echoes. And you like the observers before you must listen. Reflection doesn't fade when the light does. It lingers not on the mirror but in the mind. And when the instruments finally fall silent, what remains is not proof, but presence. Even after the last data stream dimmed and the monitors powered down, the image of two worlds, sky and sea, remained suspended in Loeb's thoughts. It was as if the universe had lifted a mirror not toward the stars but toward human thought itself. Every equation, every orbit, every spectral line now seemed to whisper a quieter question. What happens when knowing reaches its limit? He sat alone in his Harvard office. The air hummed with electricity and exhaustion. A faint blue glow bled from his monitors, painting halos across the walls, one screen still streaming telemetry from the Mars Reconnaissance Orbiter, columns of numbers moving like tides. Another screen showed the last captured image of 3I, Atlas, a pale line fading into nothing. It hadn't vanished. It had only slipped beyond precision. Loeb murmured almost to himself, "All the data fit, yet none of it explains." It was the paradox that defined modern science, when understanding expands faster than meaning. Every model aligned, every hypothesis fit, yet the picture that emerged was not clarity, it was complexity. He leaned back and let silence fill the gaps between thoughts. Perhaps this, he realized, was the truest definition of discovery, not illumination, but the moment we finally see the darkness clearly. Far away under a smaller dome in Europe, Dobsonia aimed his handmade telescope toward the western horizon. The sky above him was clear, crisp, metallic. He knew the ache of almost knowing, that delicate tension between awe and fatigue. Through the eyepiece, the stars looked closer than ever, and yet they spoke nothing. Somewhere out there between Mars and Jupiter 3Rs, Atlas still glided indifferent, elegant, and untouchable. Science called it object. His heart called it question. He whispered to no one, maybe questions are just stars that never stop burning. Across the Atlantic, Burchett scrolled through the latest briefings pages, mostly blacked out sentences amputated mid-thought. He'd demanded truth and received paperwork. The irony was not lost on him. Scientists and politicians, two languages for the same uncertainty, both trying to describe what refuses description, each hiding wonder behind their own form of control. In Cambridge, Loeb turned his chair back to the window. Outside, autumn leaves fluttered against the glass like falling data. Knowledge, he thought, was not a ladder, it was an orbit. Every answer carried the gravity of its own doubt, bending the trajectory of certainty back toward wonder. That was why every generation rebuilt its theories, not because truth had changed, but because we had. Our tools sharpened, our language softened. We began to ask less what is real and more what remains unseen. He looked again at the data, immaculate, unyielding, and for the first time felt no urge to solve it. Perhaps understanding wasn't about resolution at all, but about learning how to endure mystery without fear. Imagine standing there beside him. The office hums softly, the monitors pulse like distant stars. You realize that the most powerful kind of intelligence isn't the one that explains, but the one that can listen to silence, to uncertainty, to itself. And somewhere beyond those quiet machines, across the long distance between Mars and thought, a faint signal continues its return, not an answer, but a reminder that even the cosmos keeps some secrets, not because it hides them, but because it trusts us to keep wondering. Perhaps you think the universe is less a library of answers than a room of mirrors, each reflection showing not what exists out there, but what we're willing to notice within ourselves. And in that reflection, curiosity lives on, eternal, patient, luminous, guiding every question we have yet to ask. Understanding does not end. It slows folds and begins again. After reflection comes return, the long drift back toward the self, where light becomes thought, and thought becomes doubt. Knowledge had become coexistence, and with coexistence came doubt, not the loud kind that resists, but the quiet, disciplined kind that listens, the kind that waits for truth to arrive on its own schedule. For Avi Loeb, doubt was not failure. It was calibration, the subtle art of aligning expectation with humility. He moved through the days after the final Mars transmission, with a steady rhythm, coffee cooling beside graphs, the whisper of cooling fans, the ache of numbers that no longer surprised him. Each dataset was perfect. Albedo, thermal emission, trajectory residuals, everything in order, everything in range. And yet the pattern refused to rest. The reflections were too linear, the polarization too strong, the tail tilted just enough to irritate gravity. It obeyed physics but not habit. It fit equations but not instinct. He remembered something an older colleague had told him decades ago during a night of broken experiments. Doubt isn't the opposite of science, it's its bloodstream. Now that sentence pulsed again, slow and steady. Perhaps the true scientist isn't the one who reaches certainty, but the one who can endure curiosity long enough for certainty to arrive on its own terms. Across the Atlantic, Dobsonia uploaded his last video. The footage opened with his telescope framed against the night-scratched metal, a human fingerprint on every bolt. He spoke softly, more like a witness than a theorist. Every time I think I've caught something impossible, it teaches me that maybe impossible is just what we haven't measured yet. His voice trembled, not from fear, but from the fatigue that follows wonder. You could hear it, the hush of a man who had stared too long at silence and still chosen to call it beautiful. Meanwhile, in Washington, Burchett faced a different species of doubt, political, procedural, human. His hearings filled with pauses instead of answers, questions met by redacted lines. He began to suspect that secrecy wasn't always conspiracy. Sometimes it was confusion disguised as control. In his notebook, he scrawled, "Science doubts the unknown. Government doubts itself." And maybe both were symptoms of the same condition, the fear of realizing how much we still don't know. First, we observe the act of opening our eyes. Then we hypothesize, daring to imagine the pattern behind the light. We verify, letting reality confirm or humble us. And finally, we doubt, not to destroy knowledge, but to keep it alive. Then around that circle he drew a smaller orbit and labeled it wonder. That was the hidden equation, the recursive loop that kept discovery tethered to humility. Doubt wasn't a detour from knowledge, it was the gravity that kept knowledge from drifting into arrogance. He looked up. Outside, the night was clear, a thin frost silvering the glass of the window. The computers hummed softly behind him, still processing data that might outlive their maker, and somewhere beyond Mars' Thursa Atlas kept travelling, carrying with it the unanswered questions of an entire species. Perhaps Loeb thought it wasn't teaching us about alien intelligence at all, but about the fragility of our own. Imagine standing there beside him. The air hums, the screens fade one by one into the dark. You realize the most profound form of intelligence is not the one that explains, but the one that can bear uncertainty without breaking. You can measure the temperature of a star 1 billion miles away, but you cannot measure the hunger inside your own curiosity. That too is science. Not the certainty of knowing, but the courage to keep asking. Across the void of time and space, across the instruments that bridge worlds, every unanswered question pulses with potential. Every anomaly, every faint reflection, every drifting photon reminds us that the universe does not hand answers freely. It asks us to engage. Each new measurement, each experiment, each observation is a dialogue with the cosmos, one that insists patience is part of the method. As the last monitor slips into standby, its pale glow catches in Loeb's eyes like reflected starlight. And you understand doubt like light never ends. It simply travels farther, seeking the next surface willing to be illuminated. The reflection faded, but not the silence. After doubt comes stillness, and in that stillness something stirs. Loeb realized it one quiet morning doubt was not the end of knowledge. Beyond it waited something softer, less measurable, but no less necessary, the vision to see what data could not yet describe. For centuries, science had grown out of this same impulse to imagine first, then to test. Every telescope, every probe, every equation began as a dream someone refused to dismiss. He stared at the faint trace of 3i Atlas on his monitor, now little more than a blurred dot crossing the solar system's outer arc. There was nothing left to measure, yet the image pulled him in a small, luminous fragment drifting through darkness, carrying questions heavier than itself. He wondered if the universe had designed mystery not to hide from us, but to keep us moving toward it. In his notebook, he wrote a single line, "Science is structured imagination." He had said it once in a lecture, half as metaphor, half as confession. Every hypothesis, he thought, begins as a controlled hallucination, a picture of reality so beautiful we spend decades trying to prove it exists. Imagine being him alone in the observatory at dawn. The first light catches the rim of the telescope dome, turning the metal silver. Outside, frost on the glass glows faintly like stardust. He closes his eyes and just for a moment sees 3i Atlas, not as an object, but as an idea, the shape of a thought crossing the void. It moves with purpose, almost like memory. Elsewhere, Dobsonia dreams too. He sees the same object through his mind's lens, a rotating spindle shimmering in sunlight, neither stone nor machine, but something between. When he wakes, he sketches what he saw, not to claim truth, but to give shape to wonder. He uploads the drawing with a caption, "A hypothesis can be beautiful even before it's verified." Meanwhile, Burchett stands by the ocean watching dawn spill across the horizon. He thinks about all the classified briefings, all the guarded words. It strikes him that imagination is the one freedom even secrecy cannot contain. Perhaps that's why every mystery endures, because belief travels faster than disclosure. Loeb rereads his own note-structured imagination and smiles faintly. Maybe he thinks that is what keeps humanity in orbit, our ability to dream precisely, to shape speculation into equations, to let beauty guide inquiry without letting it replace it. Through the window, the sky lightens. For the first time in days, he allows himself to rest. The universe will continue whether he understands it or not, but within that indifference lies something sacred. A reminder that truth and imagination are not rivals. They are reflections of the same light seen from opposite sides of reason. And somewhere beyond the reach of every telescope, 3i Atlas continues its silent flight, neither confirming nor denying, only inviting. The rotations, the reflected light, the precise trajectories, they had settled into memory like a series of faint signals vibrating through space and time. Loeb let the cascade of images, spectra and orbital vectors converge in his mind. The questions of trajectory, composition and rotation were no longer isolated. They were threads stretching from Mars to Earth, from telescope to telescope, from oceans to orbit. In that network of observation, he began to perceive a subtler reflection, Not of the object itself, but of the human mind trying to comprehend it. Truth and imagination reflections of the same light. That thought lingered with Loeb as dawn slid through the blinds of his office, painting thin gold bars across the paper mountains of data. He had spent years searching for alien intelligence, and the longer he searched, the more he saw something human staring back. The cosmos, he realized, is not a stage for discovery. It is a mirror. Every question we launch into it returns as a portrait of ourselves, curious, uncertain, reaching. Our telescopes do not simply extend vision, they externalize longing. We are not only observing the universe, we are watching the echo of our own desire to know. He leaned toward the console and replayed the final image from High-Rise 3I Atlas glinting near the rim of Mars' orbit, a thin sliver suspended above the red dust. The data was perfect, complete, and yet it refused to answer the simplest question: why? Why had the object appeared at all? Why had its path intersected Mars at such an impossible angle? Why did it carry, after millions of silent miles, the faint impression of intention? He smiled at the irony. That word had no coordinates in physics, but it lived in a deeper gravity, the one where science brushes the soul. Maybe data never reveals why not because it fails, but because it was never meant to. He thought of the generations before him, Galileo with his trembling sketches of Jupiter's moons, Herschel counting stars through candlelight Sagan, whispering about the pale blue dot. Each of them had chased certainty and found poetry instead. Perhaps that was the hidden symmetry that knowledge advances not by replacing wonder but by orbiting it. The pursuit itself was the proof not of what the universe contains but of what humanity continues to become. Elsewhere, Dobsonia adjusted his lens one last time. The night's rain had left a puddle beside the dome. He turned the telescope down, not up. In the circle of water, he saw the constellations inverted, trembling. For a heartbeat, sky and earth were indistinguishable. He whispered, "Maybe this is all the universe ever does reflect." And Burchett, standing before the ocean, felt that same symmetry. The horizon split the world like an equation above its stars, below its secrets, both endless, both listening. He thought about how infinity, wherever it hides, always finds a way to look back. Imagine you are there beside him. The monitors fade to black. Only the faint hum of the observatory remains. Outside, dawn begins to dissolve the stars, each one slipping quietly into the blue. The silence is not empty, it is contemplative. You feel for an instant that the constellations above and the thoughts within share the same geometry, boundless luminous questioning. Maybe the universe was never trying to tell us who they are. Maybe it has been reminding us who we are. Every beam of light, every unanswered signal, every reflection returning home. We search the cosmos for company and find ourselves instead glimmering in the dark, still asking, still listening. The night has fallen again, the kind of silence that hums louder than sound. Above us, 3I Atlas has already passed beyond Jupiter's orbit, its reflection absorbed by distance. No telescope can follow it now. No signal can recall it. It drifts through the dark, indifferent and perfect, and in that indifference it becomes timeless. At NASA's Jet Propulsion Laboratory, the servers still hum, holding the last fragments of data. Pixels, spectra, polarizations, each one a syllable in a language we're still learning to read. Nothing in those numbers declares revelation, but nothing closes the case either. They remain suspended, persistent, waiting. Avi Loeb rereads his final report before publication. The conclusion is cautious, no definitive evidence of artificiality. Between the lines, though, the wonder remains. He knows that truth is not a snapshot, it's a moving target shifting each time we dare to look again. Across the world, Dobsonia uploads one last frame. No voiceover, no claim, just the Martian night, faint and steady with Earth, a single glint in the distance. It's his quiet way of reminding us that discovery doesn't belong to institutions. It belongs to whoever refuses to stop wondering. And Burchett, stepping out from another late hearing, looks up through the city haze. The streetlights scatter like misplaced constellations. He says to no one in particular, we'll keep asking, that's the job. Different people, same vocabulary, the grammar of curiosity. Somewhere the deep space network keeps listening. Antennas tilt, receivers hum, not following anything specific, just continuing the habit of attention. It feels almost human, that patience. Maybe that's the real experiment we're all running, not proving but persisting. Imagine you're there now under that same sky. You can feel the echo of everyone who's looked up before you. Kepler, Sagan, Loeb, and the unnamed stargazers who charted the heavens with their own eyes, all asking some version of the same question. What is this vastness trying to tell us? Maybe the universe doesn't answer. Maybe it just keeps existing, patient, consistent, instructive. Every comet, every reflection, every silence. Each one a reminder that humility is a form of intelligence. Science will continue, new telescopes will wake, new anomalies will arrive, and through it all the same principle endures: no idea is sacred until it's tested and tested again. Verification isn't the enemy of wonder, it's what keeps wonder alive. And even as the data stacks higher, we'll still dream because imagination is the part of science that stays human. Maybe that's what Three-Eyed Atlas came to show us, that between truth and belief, between knowledge and mystery, there is a quiet territory called awe, and that's where understanding begins. So when the next silence falls and the next unknown crosses our sky, we'll listen again, not for confirmation but for conversation. Because the universe doesn't speak in answers, it speaks in echoes. And maybe that's the clearest verification we'll ever have, not that we've solved it, but that we're still asking and still awake beneath the stars. If you've followed this journey through Mars oceans and distant signals, take a moment now to pause with wonder. Consider hitting subscribe or like if this exploration of curiosity, science and imagination resonated with you.